This conference will now be recorded.
So we'll go Nick, Trent, and Marek in that order.
Yes, thank you, Bob. Yeah, so my marketing team identified that there are panels at Supercompute every year for interesting topics that may or may not create some debate or interesting exchange among participants. And the one they identified is the one that similar thing that you and I had done on LinkedIn, which is a panel around the use of chiplets in high performance computing, and whether there's an open chiplet ecosystem there, or are the chiplets going to be custom designed and captive to the AMDs and Intels of the world. So that's the kind of the theme there. And I sent the abstract to the group email, so hopefully most people saw that last night. So what I'm looking for is any volunteers that would think that they would be good panelists, and we can start there, because obviously you need to be there in person. It's in November in Denver this year, so obviously you would have to travel and have your company sponsored and all that.
Hey, Nick, just to let you know, the OCP is planning to have a presence at Supercompute in November, probably have some sort of booth. And so we can coordinate and work to amplify the panel and whatever else we can do to help support it.
Sure, but the first thing I need is volunteers or people that would be on the panel, right?
So, no, I would definitely love to participate.
I'm sorry, who's that? A lot?
John Shelf.
Okay, and you're with who? I'm sorry, I can't see right now.
John's with Berkeley Labs.
Berkeley Labs, okay, all right. The best thing to do is just, the people that are interested in, can you just reply to me to my email, which is nickiliadis@acronics.com.
Okay.
Anybody? So Nick, do you want to go with the abstract for a minute, or you think the mailing list's enough? I'm asking.
Let me say, does anybody here not get it? Let me just start with that this way. I'm repeating myself.
I did not.
The problem is I'm on my phone. I'm not in front of my computer.
So. Oh, hang on. Let me see if I can pull it up. Give me one sec.
Yeah, I think my email is my previous email, so I think that's one challenge for me. I'm not getting emails.
Yeah,
this cache.
Yeah, I don't know if I got the email. Could you type it into the chat maybe?
Yeah. Give me one second. I'm trying to find Nick's email from. I think it was a response, right?
Yeah, I replied to your agenda for today.
Yeah, you did. That's what I remember. Yeah. Okay, so give me one second. Sorry, Nick. It's going to take me a minute.
No, it's okay. Well, it's going to take me even longer because I'm not in front of my computer.
Here I found it. Okay, Acronics is an exhibitor.
Are you presenting?
Yeah, give me one second.
Okay.
There.
Okay, there it is. Okay. Yeah, so we have an exhibit there. We have one of the booths at the exhibition center. And so a discussion on whether there will be an ecosystem or a marketplace of chiplets that will be available for system developers to use to build data acceleration package devices. Weigh the pros and cons of off-the-shelf chiplets versus custom designed chiplets. Chiplets could be processors, GPUs, networking interfaces, memory controllers, or FPGAs. Obviously, we're interested in the FPGA aspect of it. Then this is a questionnaire I filled out for the SC22 to submit it. The panel will consist of the panel will discuss the various benefits and challenges of chiplet-based system design and manufacturing of package devices that are used in the design and development of supercomputing HPC systems. These benefits include better reuse of IP, better cost, more flexibility, and the ability to mix various types of semiconductor die into a package. The challenges include more complex packaging, emerging electrical and mechanical standards, and more complex supply chains. And then explanation of why the chip panel will attract a good audience. Chiplet-based design systems now becoming mainstream with companies such as AMD and Intel using them across their product offerings. The technology the technology allows us to further progress Moore's law and provide higher level of integration in the systems being developed, deployed. And then why would the audience be interested? It will help educate them about the new emerging area that is enabling companies beyond just the large semiconductor manufacturers to build complex performance systems. using chiplets instead of discrete devices or modules. That's how far we got.
Yeah, so I'd recommend in the explanation of why it would attract a good audience, you should also put in there something about, you know, emerging open chiplet ecosystem, or that point out that, for example, that AMD has publicly announced that it's going to open up its chiplets platform so that third parties can insert chiplets into their package.
Okay.
The reason why you want to do that is that SC is a very academic-ish conference, and so when you make panel proposals that sound too much like they might be advertising AMD or Intel products, then you can get a panel shot down for that. So you want to make it tend more towards the open and have some hooks for the academic participation.
Okay, thank you for that feedback. That's.
Oh yeah, just FYI, John's pretty experienced in the supercomputing world, so he's a leader in supercomputing world. So yeah.
Yeah, I'm chair of the International Supercomputing Conferences here. That one is more friendly towards industry, but the U.S. Supercomputing Conference tends to be aggressively against that. So you have to make it sound more academic. For AMD, do you have like Gabe Lowe or anybody signed up from AMD to participate?
I have nobody signed up. That's why I sent it out to this group to start with.
And is it due tomorrow, you said?
No, it's due April 17th. So.
Oh, we got time. Oh, yeah, sure.
No, this is
No, I can get Gabe. Gabe participated in the panel that we put together with Bappy for the Semicon.
That would be great if you could reach out to him and just put him in contact with him, and we can coordinate the submission.
And Nick, for what it's worth, we're also trying to sort of shift the conversation towards a chiplet economy rather than an exclusive focus on the ecosystem.
Yeah.
Okay. Yeah. All right. Ecosystem economy. I guess they're similar but not the same.
Exactly.
Okay.
The ecosystem implies an emphasis on interoperability, and economy implies an emphasis on getting started, tools, chiplets, and everything else.
So okay. So ecosystem is the tools and everything like that, right?
Yeah, but in general, it's like there's a heavy emphasis on interop and marketplace, and I think we're making a lot of progress where there's tools available to you that we're calling that collection of activities a chiplet economy.
Okay. All right. So chiplet economy includes the tools and how
Exactly.
you manage the supply chain and all the other
tools,
aspects.
IP vendors, standards,
Yep.
the chiplet description formats.
So
Okay.
I don't know if it's relevant to mention it here, but in the OCP HPC sub-project, I'm trying, you know, we've got this direction of trying to create a maker community around this HPCM module that we're developing for both CXL and chiplet enablement. And it's sort of very embryonic on the chiplet side right now, but I don't know if that would make sense as being part of this or something separate.
I don't know if it's got a chiplet theme. I guess yes, or with chiplets.
Yeah, so I'm hoping that we can make you know, it'll be a bit when I present on the 21st of April. I'll try and articulate some more of the reasons. But if we've got a maker community that can people can rally around, that's so sort of the physical implementation is what, you know, how do we move forward as a community.
Got it. Does anybody have a contact at Intel that? Yeah, I'm probably going to send this out to the UCIE mailer as well, just to see if anybody.
Yeah, I think that's it. I was going to say it's worth contacting them. If you don't have anybody, there are a couple of. We've been working on a modular packaging proposal. John and I have been working on a modular packaging thing with a fairly wide collection of people.
Okay.
So if you don't get any takers on the UCIE, I'm happy to. We will get somebody from there for sure.
Okay, perfect. Yeah, I'll just have to find the right. There's a lot of groups there. I got to find the right one to send. Probably.
I can help on that.
Okay, all right. If you offline, if you could just send me something. Thank you. All right. That sounds like there's interest. So let's, again, this is a group thing, right? I mean, we're just trying to be the coordinator, but obviously having multiple companies or institutions participating make it that much more interesting.
Yeah. Would you be interested in having anybody from DARPA or Subu from UCLA?
That would be, I mean, again, if you want to make it academic, I guess do the national labs also. I mean, County Berkeley, I just heard, right? So,
yeah.
At some point, we're gonna. I think they also try to limit the number of panelists to like 5. So we got to pick.
Yeah.
We got to try to make it.
We'll be cautious when you start getting close to the limit. But five is definitely the upper limit. So at DARPA, they have a new program manager there who's leading their 3DIC and chiplets effort. So this would be
yes.
That would be great, actually. Yeah.
Judge, I'll connect you guys offline. Actually, I'll do it after I stop sharing my screen. So, okay. Nick, do you know how to reach John, or John? If you don't, I'll connect you offline.
Yep, please connect me.
Yeah.
Yeah, there's my, in the chat is my email.
There's your email. Okay.
Perfect. Let's see, where is the chat? All right.
Okay.
All set. Thank you.
Perfect timing. All right. Thank you, Trent. It's all yours. Do you need to share the screen? Would you like to share your screen?
Yes, I'd like to share my screen.
All right, hang on.
Okay. See, I'm made a presenter.
So Trent, while Trent's getting set up, there's a discussion on whether we can get together a response to the CHIPS Act.
Okay. Let's see if I can get rid of this stuff on the side here. Screen right now?
We see your desktop, not your screen, not anything you're sharing. We see the entire desktop. Yeah.
Okay.
I could see your slide. Yeah,
right.
Now I can see your slides.
Okay. Okay. I've got this sidebar thing that's showing up on my screen. Can you see that or no?
No, I don't think so. At least I can't.
Okay. I need to get rid of that. Let's see. I can do that. Because I can't see.
One quick question: does everybody knows how to join the mailing list, right? You go to groups.io and look for the ODSA group under OCP and just subscribe to the mailing list. So it's a sort of a self-subscription thing. So please get on the mailing list. Go ahead, Trent, please.
Okay. All right. I'll try to do this, even though.
Well,
I'm not
you know what? Just get off slideshow mode. Get off slideshow mode. It probably works better. I think they're throwing this for a loop.
Okay. What are you seeing now? Are you seeing the whole presentation?
We're seeing the presentation in slideshow mode.
Okay. Yeah. See, the problem is on my screen, the GoToMeeting sidebar is right on top of it. I'm trying to figure out how to get rid of that. Got it. I got it. Okay.
You know those really basic face smush apps? Yeah.
Yeah. Okay. All right. So first of all, some background on the CHIPS Act. I'm sure many of you are aware of this. It's of course U.S. government. Go ahead. What is there a comment, or maybe somebody's just not muted? Can you hear me still?
Yes, we can. I think it was just
okay.
All right.
Okay. All right. The CHIPS Act does provide $52 billion for semiconductor manufacturing in R&D. And there's
ban all apps.
also a refundable tax credit for certain capital expenditures. So the $50 billion is allocated over 5 years for the CHIPS America Fund. I've highlighted what the important part is here. If when putting together a proposal, we need to develop domestic manufacturing capability and research and development. And so I think for chiplets, it's probably more in the research and development side of things, but there might be some manufacturing aspects to it. The funding is $2 billion for the DoD microelectronics Commons, and then the NIST R&D has $11 billion funding. And I picked these two because I think these are the two areas where we would probably want to look at least that's where I'm focusing for opportunities to get some funding for some R&D projects. So first, the microelectric commons. So some regional innovation hubs have been established. Each of these innovation hubs actually put together a proposal and an application to the DoD, and so these have already been established. That was, I think, completed right around the beginning of this year. So you can see the states that are highlighted here have the innovation hubs. We've been working closely, of course, me being in Austin, with the Texas hub, and also we have a presence in Arizona, and so we've been working with the Arizona hub as well. And these hubs are typically associated with universities and of course commercial businesses as well. So for the Commons timeline, you can see in Q1 there were the RFS for the 9 regional hubs. That's pretty much done, although I haven't seen the official announcement yet, so that should be coming pretty soon as far as the 9 hubs being selected. So now the next steps are going to be in Q3 this year, the awards going to the 9 regional hubs. And so this is where, not necessarily for chiplets, but for some other projects, NXP is working with some of the regional hubs to put together some proposals for funded development. And that's what these awards are, and the project selection is all having to do with the proposals we put forth along with these hubs. And so a couple notes: the hubs may propose a core facility, which may be a manufacturing facility, an OEM, or possibly a university research facility. And these core facilities may be considered as the hub lead. So the second part of this is the NIST R&D program, and you can see that there's multiple parts of this, and that's why if you noticed on the first slide, even though it was 50 billion total, there was only about 13 billion that I had identified, because the rest of the money is going also to the manufacturing institutes, metrology, packaging. So NIC, which is a public and private consortium, which will serve as the focal point for semiconductor research for the nation. So some consortiums have been established. This is actually just from the NIST website. But on the right here, whoops, sorry. On the right side here, I'm listing just some of the consortiums that have been established. There's other ones also. These are consortiums that NXP is already in discussions with regarding proposals for R&D. And so you can see this MITRE Ingenuity. I think this is a pretty big one. It includes AMD, Qualcomm, and it's based in California. UC Berkeley and Stanford, Microsoft is part of it. A lot of people are part of this MITRE Ingenuity program. It's a pretty big one. The Texas Institute of Electronics has been established at the University of Texas at Austin, so that's local here in Austin. So we're, of course, trying to see how we can leverage this consortium. The ASIC, American Semiconductor Industry Coalition, that's in upstate New York. It's there's IBM, AMD, TI, but also as far as universities, MIT is associated with it as well. America's Frontier Fund, I don't know about that. And then also at Arizona, there's Arizona State University is also leading a task force as well. And then SRC, which NXP is a member of SRC also, the Semiconductor Research Corporation, has the MAPT consortium as well. So these are all opportunities to participate in research. There's also the manufacturing side of it, right? If there's any ideas about establishing manufacturing capability in the U.S., there's also the Manufacturing USA Institute, which is focused on advancing, commercialization of manufacturing technologies, in the United States, and also the National Advanced Packaging Manufacturing program. So ways to put the chips together. Specifically, it's the text here in the NIST R&D program is specifically discussing packaging chips together, right? So that's really speaking a lot directly to chiplets. Now, at NXP, of course, we're not probably not so much focused on the manufacturing part of it here in the U.S., but some of you may be or may know of other companies that want to try to establish some manufacturing technologies here in the U.S. So timeline. This is a summary of the timeline for both of the areas which I've mentioned. First of all, the DoD microelectronics commons. The proposals were submitted by these microelectric commons organizations February 28th, and so now the award decision process is running right now, and hoping to have award decisions by April, and then contract agreements and funding going forward. So the award decisions are essentially awarding the commons, but as far as the project details, there's still some work that can be done as far as putting together project details for the funding. So it's really not too late to work with these commons to try to get certain projects funded. And in fact, if you take a look at if you communicate with them and see what types of projects they have in their proposals, some of them may already have to do with chiplets. I haven't looked at what they have in detail yet, but I do know, for example, one of the projects that NXP is looking at is certain IP in the form of chiplets, for example. And then for the NSTC, the proposal development is running right now. And these proposals, the RFP process is May and June. You can see a question mark here. It's kind of hard if you go on to the government websites to really have a clear view of exactly what the timeline is. So this was actually put together by somebody within NXP, his perception of when the timelines are, with a due date in July and then award sometime in Q3, and then the funding from there. So finally, just some ideas of how we could leverage CHIPS funding for the chiplet infrastructure. First of all, identifying what technology development needs are required to help bolster the chiplet ecosystem. I've mentioned this before in our meetings. Whoops. That the packaging the package cost might be kind of restrictive for some products. So lower cost packaging options are definitely, I think, a need to bolster the chiplet ecosystem. Other areas where chiplet applications could apply are things like low latency memory, accelerators, and then also, I've also mentioned this before in our meeting as well, is the interface scaling, making sure that we're not putting, a huge pipeline where we really just need a small one, right? Where we could scale the interface down to what's really needed, instead of having this larger interface consuming more power and energy than we really need to, more bandwidth than we need to. And then also, just what kind of infrastructure building blocks would there be? Again, to develop the ecosystem, things like cores, analog IP memory, the list goes on and on. And to do this, what we need to do is engage with partners. Take a look at the DoD Commons or the NSTC consortiums. I think some of you may already be involved in this. And so I'm sure you're familiar with the process. So we probably would need to take a look at the proposals that are in flight. If we see compelling areas where this might be a good opportunity to leverage the CHIPS funding in line with the requirements for CHIPS funding, we may want to look at refining the scope of some of these proposals, leading to securing the allocation of funding. And then also we'll need to understand, for the people leading these consortiums, what are their expectations and requirements in order to support a chiplet type program. Okay, questions or comments?
Trent, you will be able to share that timeline estimate because it sounds nice and looks like somebody's put some thought into reading the doc.
Sure. Yeah.
This is a very nice proposal. Thank you. I'm glad you're doing
it. Yeah, and if anybody has any ideas, feel free to ping me, we can talk through them, or ping Boppy, and we can get together. We can discuss it some more.
Yeah, there's also an interesting feature of the DoD Commons, at least, is that it's a kind of contract where the SOW can be fluid, where they can add things that weren't in the original proposal at any time during the project, and that was kind of interesting. And the part that was the other part that was interesting wrinkle in it was that they require each of the commons to focus on one of the 6 areas that they defined. So it's like 5G, 6G is one of the things, AI, machine learning. So it's very application driven. In each of the centers, all of their resources are oriented around those 6 areas that were predefined by the DoD.
Yeah, exactly. And like a couple of them that you mentioned, like the AI and machine learning, I think that's an interesting case where I think we actually have members of this of the ODSA that are working on those types of technologies, and with the thinking that it would be offered in kind of a chiplet type of form. And so and that's where it might get a little bit sticky, right? is some of the universities are also working on, AI accelerators and things like that. And so we could go in there and say, hey, maybe you want to consider chiplet form, but at the same time, there's people in the industry, some people probably on this call that are working on those things as well. So
I see I found the list. Yeah, it's electronic warfare, secure edge in IoT computing, AI hardware at the edge, quantum, 5G, 6G, and commercial leap ahead technologies.
Okay, John, you went through those super fast. I couldn't catch.
Oh, sorry. Well, here, I can share the screen with that really quick.
Give me one
Okay,
second. I think I will make you the presenter.
Yeah, I can. All right, so now I need to see it open in system preferences. Oh shoot, no, it's not going to let me do this, is it? Sorry.
Okay, that's fine. I'll add them offline with you.
Yeah, I'll so I can type it into the chat.
That's fine. I think I got 3 out of the 5. So there's one idea, Trent. I was really excited to see your email, because there's one idea I've been floating around, which is the idea of like focusing on really rapid prototyping, a quick turnaround facility. And is Kash still online? I don't think I can see him.
Yes, I'm online.
Okay. So I've been floating this idea in a couple of places, and the reaction so far has been pretty good in terms of focusing on a facility which turns things around super fast in limited quantities, a packaging facility that aim for a substantial improvement over what happens today. So the idea is that we'd get together a coalition that whose sole purpose was to enable much faster prototyping using some of the technologies you have in your list. So it's also a quick turnaround versus. All right.
Ken, thank you for your presentation. I had a question about just in general how you are, as a company, thinking of approaching this. So I've been also involved in some of these discussions with ASIC and other groups, and I feel like one of the issues that I'm still not clear on is kind of the boundary between research and something that is, let's say, a prototype for product development, and questions around like basically who holds rights to the developments that come out of these things. Do you have any idea, or like how's your thinking around this? Like how would you want to leverage the funding, like kind of what stage of product development?
Yeah, I think we're definitely pre-product development, and so we're really looking more at some foundational IP type development where we could see it in a product in the future. And of course, like you said, if it's going to be in one of these consortiums, it's not going to be owned by us, right? And so I think what we're trying to do is get some funding for some key research, let's just take AI accelerators, for example. Get some funding for some key research to get that type of IP developed faster, so it's available to us, and of course it'll be available to others faster as well. So we're taking the strategy of identifying the key IP that we think we're going to need in the future, to help our products be successful, but taking the stance that this is IP development, to get it done faster. Of course, we're not doing the IP development; we're participating for use on future products. And so, definitely, we're trying to keep the product, the near-term product needs or development out of it, because this is public, right?
Yeah,
I don't know if that really helps.
So in addition to this, I mean, I'm going to talk from Intel perspective because with the microelectronic commons, you can apply as a hub or as a core. So there are different model, and if you apply as a hub and a core, that means you become a hub. There is candidate prototypes, and it's the core that will own the commercially viable prototyping. Because when you look at the microelectronic commons and there are different stages. There is a candidate prototype, there is a working prototype, and at the end, there is the commercially viable prototype. So it's the core, the people that applied for the core will own the commercially viable prototype, but then you have candidate prototype as part of a hub. So sometimes the hub and the core is a little bit confusing, but you have to know what you apply for. Do you apply for a hub, you apply for a core, or you apply for a both? The models differs.
Yeah. Yeah, I wasn't clear on who would actually own the IP. I thought for some reason it was pre-competitive somehow, but you are right that they have this idea that the universities and the labs would be, 200, millimeter wafer service, 8-inch scale prototypes, and that the cores actually then take a success. They use that as a filter. And then anything that is successful at the smaller scale then gets scaled up to 300 millimeter commercial wafer service to demonstrate that you can bridge that gap from research prototype to scalable production prototype.
So first off, the two questions or three questions. One, should we reach out to the existing coalitions? I mean, I think I know a couple of people on ASIC. I'm guessing. I don't know anybody else on either the Texas one or the Berkeley one. That's question number one. And question number two, does anybody have any interest in putting a proposal together? And finally, the topic of the proposal. So maybe we'll go through those in that order. Anyone want to sign on to Trent's thought about working together to put a proposal together?
So this is specifically for microelectronic commons or other, because there are chiplet related RFS. For example, steam pipe is pretty much a chiplet initiative more than these. I mean, I think like for the microelectronic, and I agree when that was flashed, there are certain 6 segments that you apply to. Chiplet might be a part of that, but there are better suited kind of proposals and project. I mean, something that jumps to me is a steam pipe, because the steam pipe is all about the chiplet and chiplet development.
Right. So at least in my mind right now, the bigger question is, do we want to work together on something tangible like this, and then we go off and hunt for the right program? I think Trent has sort of seeded the thought of, should we explore working together to propose a facility, to propose IP development, or some combination? So, should we work together, and which program?
Well, Bapi, I think I've already said I'm very interested in studying that packaging thing, and also I've been talking to a number of customers, obviously as a little startup, and a lot of them at the lower end in terms of performance, with sensors and so on. A flip chip solution is way too expensive. So some sort of innovation on applying chiplets to lower performance, maybe that can fit into a multi-chip module type thing. So I can see a lot of areas here. I think we need to talk about this offline, at least within a couple of us that are interested in doing something like that. I think that there's going to be a lot of innovation in that end of it. Not just the super, all about high performance computing, but there's the real world where, you've got real modules that will never be chiplets. How do you put it all together in a single module, right? And still be able to do something cost effective and gain the advantages of lower power and scaling and things like that. So
yeah,
Yeah, Cash, that's good. And that's, I had mentioned scalability also on my slide because, because the technology, the packaging technology to put chiplets together exists, right?
Yeah.
Intel can do it, AMD
I mean,
can do it.
yeah.
So it's not so
obvious,
much
man.
developing. It's not so much developing a new or advanced technology because these advanced technologies are unaffordable for a lot of us, and so that's kind of my view on it. Also, is to make it more common, for, like you said, the lower ASP type products.
Right. I actually talked to yesterday to somebody at to IMEC, and they're looking at they were starting to look at chiplets, and they've got some automotive manufacturers, and so because chiplets is a hot thing, they're all saying, hey, let's do something in chiplets, and then the real applications are a few hundred megahertz, right? So I'm just using that as an example. I mean, I know that here we're a different market, but so anyway, I know I've got an action item within the team to talk about lower frequency and so on, but I'm definitely sensing a gap, right? Where not everything is running at 2-3 gig CPU speed. You know what I'm saying, right?
Right. Give me 1 second. Excuse me for interrupting, Kash. Hey, Marek, should we should we just push the business discussion next week and keep this going, or do you want to do a 15-minute?
I think that's good. I think we have that's probably a good idea.
Okay, then we can keep going. All right. Thank you. Sorry about that.
I just wanted to add, from the OCP perspective, if a group of people wanted to get together to look at putting in a proposal, the OCP would want to look at what we could do to support that.
Well, that makes perfect sense. Yeah, I mean, I think it has to be done as part of a team, right? So it's taking what OCP has, which is, I think, focused on very much high performance. Obviously, that is also applicable, but how can we take this standard? So still use a standard, right? But make it applicable to people that want to build, lower cost or lower bandwidth. How can you do 3 or 4 pins? So I've already started looking into that a little bit myself, right? Because I definitely sense a huge opportunity here. That's a real world opportunity. So anyway, so I think we need to go, and I know there's a business group call at 11, right? So maybe we can talk about that during that call, or if it's appropriate as well.
Yeah, sounds good. I personally also think this scalability part or lower bandwidth option, that there would be a need for that or an opportunity there.
Right. No, I think I've now heard this from a lot of people. So yeah.
Okay, so we're seeing lower bandwidth as scalability as one ideas, and I will also push my more rapid turnaround as one important thing.
Well, I think that goes without saying, Bapi. You gotta be able to try different things, right? So
yeah, I think something where you can turn around a product in 4 weeks.
Yeah.
A prototype in 4 weeks.
Yeah.
Actually, I'm seeing lower bandwidth, and I'm working directly on one which would be at the lower end, but would benefit from the chiplet approach as well.
Yeah.
And maybe when we look at this ODSA, it's all about a standardization across a wider community, whereas the big boys are going to do what they're going to do anyway. So I think it's probably the best way to get this ecosystem going. If we can bootstrap it on off the organic lower end, then that might be a better way to get it going anyway.
Excellent. I heard someone else trying to jump in. I thought I heard another voice.
Yeah, that was me.
Oh, that was you? All right, fire away.
Yeah. Hey, Cash, so a question for you. So when you talk about the lower end stuff, you're talking more legacy stuff, which is currently, and I'm just gonna phrase it the way I think it is there's a lot of legacy stuff which large PCBs, wire bonds potentially put together, creating probably large form factor systems. And you're saying, how do we innovate that to make it work with using a more and a little more advanced packaging, not necessarily top end of line, to reduce form factor but yet keep the cost down. Am I paraphrasing that correct?
You are spot on. I mean, I was reading about, wire bond, and people are saying you can do wire bond to, 30, 40 micron pitch, right? As long as they're in line. Well, to be honest, I haven't been in the business in the manufacturing for a long time, so I'm surprised you could do that. So that opens up a lot of capabilities, right? So you could have obviously the traditional wire bond, but you could also have, for new sensors and other things, a much tighter wire bond if they're. So I think that should all be on the table. But yes, I mean, I think several people have said, you need to be, at some point, you need to be able to mix either a wire bond, whether it's optical device or a mixed signal device or sensor devices. I mean, there's so many darn devices out there, potentially in die form, and run it at a lower frequency, and then go into a chip, and that chip then could also be able to support, UCIe or a bunch of wires or whatever, right, on the other side. So, and it needs, ideally, it needs to be seamless, right? So
wait. Gosh, we're getting into our favorite topic of geeking out on the tech specifics.
Right.
And we're down to 10 minutes. Actually, this topic has a lot of interest. I'm glad Anu's interested, Kash is interested, Marek, Trent. So there's the lower end scale of the Trent's proposal seems to be very interesting to lots of people. And let's talk logistics. Do we want to do something? How do we want to do it? And then how do we reach out to, maybe ask, do we want to do something and how do we do it? Maybe stop there and I'll take some notes.
Well, I'll also, in terms of reach out, if the Northern California hub gets funded, the AI ML is led by Saif Salahuddin here at Berkeley and Philip Wong at Stanford. And so I can, if you have anything in the AI application area that uses chiplets, let me know and we can connect you up with the Northern California Microelectronics Commons Hub.
It's Cal and Stanford.
Okay.
So we can reach out to the AI hub. I think we can reach out to the AI coalition, right? As well. I think it's a coalition. Yeah. Excuse me.
And it's Cal and Stanford and Intel.
Cal, Stanford, Intel. Okay.
Intel's the core.
On the call, is anybody? Does his interest on the call? Does anybody's interest translate to the potential to active participation? I think John, you can participate, right? And
we're definitely interested.
Yeah. Okay. Anybody else? I'm asking. I'm trying to figure out how do we? What are the logistics of moving this forward?
Yeah. Well, obviously, I'm interested. So.
Papi, from an Intel perspective, we did apply, as it was mentioned, for the AI as a hub. We applied for the 5G, 6G. We applied for the warfare. So there are. We have to see what we get out of if we become a hub, and that's where the partnership comes into play. So maybe I can update once we have. I think like we applied even for the secure edge as well.
Okay.
As a hub.
Okay, so let's say we do what we get ourselves ready to participate in terms of a packaging proposal, right? Either scalable, rapid prototyping, or some combination thereof. Who online is interested in putting together such a packaging proposal? Trent, I'm assuming you'd be interested, since you got the thing kicked off. So Trent, John, Kash, anybody else?
So when you say packaging proposal, what can you just clarify that, Papi?
That's about as clear as I can get right now. I think the question is, can we do? There are two ideas that I've heard: some kind of a prototyping or IP proposal for lower cost packaging, packaging at lower end of the scale, and my pet favorite is much more rapid prototyping. Those are the tools that.
I would participate because this maker community, which we've got with the HPCM, although it sounds like high performance compute, which it is, but that is all about prototyping and getting people started and organically growing this. So, and it brings in the dynamics of the lower end stuff as well. Or at lower end compared to where we're trying to go with the, what the big boys are really driving. So I'd be happy to participate from an OCP perspective.
And the other thing that's a hot button for me is known good die, right? So I'm very interested in being able to, if we can work together and validate, testing singulated die. And I've been talking to TestSolve and some of the other people, and they're on board. I talked to gosh, I'm getting so old, I keep forgetting names. Mike's on the call, by the way. So I think there's interest in, okay, how do you validate and test the die before you assemble it and blow up the rest of the chiplet ecosystem, right? So I think that's all tied into this packaging thing as well, right? So how do you package it where you can mix technologies, and also how do you validate the die? Because that's the known good die conundrum is also something that's sort of obviously, if you're going to be real about this ecosystem, it's critical.
Yeah, and I think the packaging part of it, baked into that is going to be the scalability, right? Taking this interface and figuring out how to make it scalable, where as Alan had mentioned, where it can just be 4 lanes or just a few pins and still give you the desired results you need for the particular product or IP. So I think they go hand in hand, and I like the known good die part of it too. I think that also fits in very well.
Oh no! One rule is we can't agree with Kash. It's bad enough when we agree, but we don't agree with him.
Okay.
But Trent, I have a question. Do you see this as part of the scope of the microelectronic commons? Is it within the scope you see it?
That's a good question. I'm not really sure. I need to go back and look at the scope of that in detail and see if that's really where it falls.
Wait, so I apologize again. I want to come back to logistics. One quick call. Is anybody else interested? I think I'm trying to figure out whether we make this a part of the business work group, a separate group that meets on its own. How do people want to try this out? I guess is my question.
Yeah. Well, I think we could start right as a separate group. Maybe those who are interested, we can meet and try to hash out some of the logistics. I think right now it's kind of broad and undefined. As far as even which area would we focus on? Would it be the microelectric commons? Would it be the NSTC? So I think a group of us needs to kind of look at the logistics.
That's a second order question. Then the first one is, what do we narrow it down to 2 or 3 technology proposals and then go hunting for a home for them? Then I see 3 good ideas on the table here.
True. Yeah. Okay.
Anu, you were going to say something, or Marek? Any thoughts?
No, you can stick me in.
Okay, so.
Yeah, it's a good question, Bobby. So I would also be interested in participating in this. The question is how many meetings we can have where we find broad enough time slots that work for everyone. And I guess for now we have a time set up for the business group and it's kind of talking about last week's item, which is the checklist of chiplets for having self kind of compliance. So that would be another aspect. So I'm not sure if we have enough room to mix all of that in the business group, or as Trent said, for now have a separate group at the expense of maybe splitting the people a little bit.
Right. Well, to me, this the checklist is a sort of a longer lead item. This one's if you can pull it off, it's a nice thing. It's worth a shot, but it's your call.
I mean, I'm also happy to use the meeting for now and focus on this proposal idea.
Okay, well, maybe we can caucus offline and figure out one way or the other. I think we've got a core group. I've got 6 names so far. I've got Trent, John, Kash, Alan, Anu, Bapi, Marek, and Cliff. And we can sort of see who else is interested and string out if some kind of a proposal from this.
Sounds good.
Salim, is this something you can participate in, or since you obviously have an incredible amount of knowledge, or this is something you had to clear internally? I'm asking, not. I think I lost him.
Oops, I was trying to, sorry, I was trying to unmute. I just need more information on where this one is going, because from, to me at least, from a microelectronic comments, I don't think that's the right path.
Yeah.
But from potentially other CHIPS Act, and there is a plenty of them. I mean, there are plenty of other kind of venues for potentially funding from the CHIPS Acts.
Just so we're clear,
Yeah.
the important thing is to figure out what, and then we can go figure out where, what,
Correct.
where, and how, in that order.
Correct. Yes.
Yeah, but
then,
Salim, you obviously I think you have a lot more knowledge than I do about what the different areas are. So if you have some ideas about where we should look, other than the commons, right? I'd be certainly interested in your thoughts there.
Sure, definitely. And this is where we need potentially some of the DIB customers involved, because it's much easier to get involvement when we have some of those DIB, the Raytheon, Lockheed
I
Martin.
see. The prime contractors.
Yes.
Okay. Okay. So, Marek, if it's okay with you, I'd like to make this one of the 2 topics. I think there's something here. So, and if there's nothing, we can walk away.
Sounds good. Yeah, no, that's good. So I put in
you,
the details for the business group meeting in the chat for people that may be interested. So we're meeting, I guess, in 2 hours to discuss.
Great. I'm going to put that in here.
Oh, so Marek, was that one of the invites that came out yesterday?
No, so I asked Bapi if it makes sense to if we can get this onto the GoToMeeting platform, and for now I started with the people that were interested last week in talking about this checklist, and I guess in the long run we should put this onto the invite as well,
Yeah,
or onto this calendar lookup.
This is a secret open meeting, Anu.
Yeah, I was going to say, Bapi's been very secretive here. Yeah.
No, I'm going to help. Yeah, I wasn't sure if I could make it. Marek, I can set up a Zoom call after that. I'll send you a Zoom link for 11 a.m.
Yeah. Okay.
All right. Thanks all.
Thanks.
Thanks. Bye.
Bye.
Bye-bye.